Okay, welcome to part one of my introduction to Cables.GL. I'm definitely not going to cover everything about this great tool, but I am going to hopefully give you a sense of what it's about and why you might want to use it. So first of all, this is a hosted web application, so it's basically a website. So you need to go to Cables.GL and you need to click register to give yourself an account. So I'm already a registered user, so I'm going to log in instead. Okay. And the first thing that you'll notice on the home page is that there are all kinds of works on display. These are projects created by other Cables.GL users that they have decided to make public. And you'll notice that Cables calls these things patches instead of projects, and that's a bit of jargon worth remembering. Now, clicking on any of these patches will take you to a little view where you can run the patch and start playing with it. So this slime mold simulation looks pretty great, and it's very interactive. But here's where it gets even better. So let's click on Open in Editor. This is the Cables patch that's making the slime mold simulation actually work. This is everything. Okay, so we can zoom in and out. We can use the buttons, or we can scroll with the mouse or trackpad. You can also use the secondary mouse button and drag around to view more of the editor. And we can see how this thing is put together. The little rectangular boxes are called ops. That's short for operators. And the lines joining them are called cables. So just by reading the names of the ops and following where the cables go, we can already get a sense of what the different parts of this patch are probably doing. If we go and hover our pointer over any of these ports on the ops, we get to see not just what that port is called, but also what kind of value it's getting in or out. And we get a preview of the value that's currently in that port at the moment. And if that happens to be a texture, we actually get a little image preview of the texture at that point in the patch. So this is very useful for checking how data is flowing around at various stages in the process of layering graphics, for example. This is a fairly complicated patch, and I promise you I'll start with from scratch with something that's a lot simpler very soon. But I'm sure you can agree that even seeing this for the first time, you do get a rough idea already of what's going on here. So this is a great way to learn, since you can explore other people's patches and you can already start playing with them. This is already completely editable. But there's another tip which I have for learning Cables.GL. If you come across an op that you'd like to know more about, just click on it. So for example, this noise pop. And there will always be a button for documentation and almost always a button for example. If I click documentation, I get taken to a documentation page, and notice it's in a new tab, so I haven't lost anything that I was working on already. And on the left-hand side, you can see all the details about the op and what it's supposed to be about, and the details of what the different in and output ports do. But on the right-hand side, you've got another cables patch, and this is live. It's running in the browser right now, and just like any other cables patch, again, you can open an editor. This means that it's also editable. So now I can explore and I can play with another patch. And if I want to make it my own, I can click on the title and click clone patch, and we can call it something useful like starting point with noise. So this is actually a pretty great place to start with some of the basic elements that you'll typically work with in your average cables patch. We've got a main loop op over here, which is essential. So this loops 60 times a second, or as fast as it can go. sending out triggers, which are a kind of message that you can send along cables from the one output port to one or more input ports. And the main loop sends these triggers in order to tell other ops that they need to update or draw again 60 times a second. The main loop in this case is connected to an image compose op, which in turn triggers a draw image op, and that in turn triggers a noise op, which is the one that we were interested in the first place. So you can see here that data typically flows downward, and that's because the output ports of the ops are always at the bottom of each op and the input ports are always at the top. And the order in which things are triggered often determines the rendering order, for example, like which thing is drawn on top of what. The most important exception to this top-down order is seen quite often with the image compose op and a few other ops that are similar to that one. So you notice that the final step of all the things happening below the image compose, so the texture, draw image, noise, is a texture output, which is coming out of the image compose op. So in a way, we've gone kind of down, down, down through the different drawing operations. And I guess that the designers of Cables.GL could have put something like the image compose op at the end of the chain, gather all the stuff that's been drawn and stick it into a texture. But that's not how they've done it. And I think there are some good reasons for that, some of which might be technical. So, for example, the texture or the drawing context needs to be set up before you start drawing things into it. But to be honest, it is one slightly confusing thing about Cables.GL at first. But it's also pretty much the only confusing thing that you'll find, unlike Touch Designer. And once you've seen how this is done, you'll probably never worry about it again. Okay, the other area that I'm going to show you is the stuff related to the sidebar op and the things that are below it. And in fact, I'm going to emphasize that it's a different bunch of things by moving them to the side and creating an area around the selection. And we're going to give it a label. So we're going to say GUI stuff happens. And this is just to illustrate another thing that I like about Cables.GL is that it gives you lots of tools like in order to organize your workspace visually, since it is a visual tool. Again, this in contrast to Touch Designer, which gives you very few tools to do that kind of thing. So what's happening in the sidebar is that you are being given a really easy way to add interactive GUI, graphical user interface elements into your patch. Like here we've got a slider and we've got a toggle which can typically used to stop and start things or switch things on and off. And you can see that, for example, the slider value, the number, and it's going to control the amount. And in this case, amount means amount of noise. And I'm just going to pause here to say something about the GUI tools that Cables.GL provides. This is obviously super useful for yourself as you are, trying things out and you want to be able to manipulate things. But it's also very useful if you're going to share this with someone else. It could be a collaborator, another designer. It could be the client, even if you're going to kind of show a prototype of sorts, and I'll show you how to do that. Someone that doesn't necessarily need to know anything about Cables.GL and how the editor works. But I don't want you to think that the GUI is everything that you need to make. As easy as it is to set this up, which is great, you didn't need to do any HTML or write any code. But of course, this is a visual programming environment, so there are lots of ways to play around with values and change things and see what the effect is without necessarily having to build a GUI for that. So, for example, if we wanted to play with the scaling, the size of this rectangle, which is what's actually displaying the final output here, you can see that there are values for width and height. So we could manipulate these directly just in here, and that would already be enough to be able to get a sense of, oh, okay, well, what do these values do and what sort of ranges make sense. You could do that without having to build a GUI for it. What if we wanted to do a little bit of animation? Okay, so we're going to add a new op completely. So I'm not going to click on any cables yet or anything like that. I am just going to use one of the many ways of adding a new op. One of which is hitting the tab key. So I'm hitting tab. A really cool one is an LFO, a low frequency oscillator. Okay, and this is the LFO. At the moment, it's not doing anything. We can see that the result is sitting at -1. It's not changing at all. It looks like it might need a time input. In case you're wondering, let's rather go and have a look at the documentation. And here they've obviously got a really nice example of how an LFO is meant to be used. So let's go and open that up. And you can see that what they've done is that they have a timer, another op that is generating time values. This is in seconds. It's going into the time, and that is making a value that goes up and down from -1 to 1 over time. Okay, so we're going to try that principle here. So we know that this needs a timer. I'm going to drag off here, and we're going to create a timer. Now we have a timer. It's sending time values into the LFO, and it's producing a result. So maybe what we want to do is we want to use that for the width. We're going to animate the width of the rectangle. So I'm going to hover over this, and I'm going to right click. That just disconnects it. There's a couple of ways to do that, but that's one. And we're going to connect up the LFO to the width. So we can change the range here. So maybe we say it starts at 1 and it goes up to 4 or something like that. That's kind of interesting. Maybe we want at the same time to make the height do exactly the same thing. Okay, so we could take this same value and we could plug it into the height. Okay, so at this point we've got something interesting. We've got a value that animates over time, and we're using the same value in two different places, in this case the width and the height. But what if we wanted to get a little bit more sophisticated, apply a little bit of math and logic? And this is where visual programming becomes really interesting, and where Cables.GL in particular does things really well. So what if we wanted to say that, okay, we've got a value coming out of this LFO, but we want the value that goes to the width to be double the value that goes to the height. So we want this thing to be stretched out horizontally, but we still want it to animate over time. So without having to write some code or write an expression or some kind of mathematical formula, what we can do is insert an op in the middle of this cable that's going from the LFO to the width input, and we're going to look for something that multiplies stuff. Oh, look, it's called multiply. What a great name for such a thing. Okay, so now you can see that the way that this thing flows, let me just disentangle a few things here, but you can see that there is a value that goes out of here, which goes into the multiplication and then goes into the width, and then there's one copy of the value that goes straight into the height. At the moment, it's been multiplied by 1, which is not very useful. So let's change this to a 2. Okay, and you can instantly see the effect that we're having. Okay, so we've applied some math now. We're actually duplicated messages, changed the value of one path and with another. So you can think about this in terms now of actually joining up your own little ops together in in a network, in a graph, that describes the logic of what you're trying to do. Okay, and we're going to do something that is not as scary as it sounds, which is we're going to start a patch completely from scratch. And just to give a sense of how that goes. So we're going to create a new empty patch. So in my blank patch, I'm going to add the main loop, which I said was essential. So in the previous patch, there were multiple things drawn, but in different stages, but they were all coming out of the same main loop trigger, which is being duplicated around. A more sensible way to do this, and the more usual way to do this, is to create a patch coming out of the main loop called sequence. Okay, and the idea is that from left to right, these triggers will be triggered in that sequence, so that you can make sure that things happen in a particular order. Okay, so for this example, we're going to be combining some 2D drawing and some 3D drawing, and we're going to be layering some things. It sounds all very complicated, but let's break it down into a few steps. Okay, we are first going to do an image compose, similar to what we did in the previous example, a very common one to start with. And an image compose, you remember, wants to draw a bunch of things underneath it, so trigger some other drawing operations, and then the final result is a texture that comes out, which we can do something with. Okay, so in this case, what we are going to draw, we're going to trigger a drawing operation. We're going to do a different type of noise, something a little bit more interesting. You may have heard of Perlin noise. It kind of makes these lovely looking smoky type of patterns. Okay, so far it's not drawing anything on the canvas yet, but we know it is rendering something, because if we hover over the texture output port, we can see it there. We might want to put that somewhere where we can keep an eye on it. So there is an op called viz texture, and it's purely just to give you a nice way of having a look at what textures are doing and sticking it into your editor. It won't appear on the final canvas. If you've ever worked with Perlin noise before, you'll know that it essentially generates noise usually in 2 dimensions. So what we can do is actually change the coordinates, shift the whole pattern up and down, and that is kind of done in an infinite way. So there's nothing if we want this to be animated, we know by playing around here that it looks pretty interesting if the X value just goes, constantly moves. So let's find the X value here, and let's feed a timer into that. Okay. And the next thing that I'm going to draw, so coming out of the second trigger output port, I am going to draw a rectangle, okay, which is actually a 3D object. It just happens to be a plane, so it's got one face. It's not terribly exciting at the moment. It just has it's just gray, it has a gray texture. If I wanted to do something a little bit more interesting with it, I could add a material. Okay, so let's say we take a basic material. Basic material does essentially a material without any shading. So we could make it a single color, all right? We could also take the result of this drawing of the Perlin noise, and we could use that as the texture. So I'm going to send the output of the image compose, which is what's actually drawing this Perlin noise, and I'm going to send it into the texture for the rectangle. We're going to make this rectangle a little bit bigger. All right. So we've got our rectangle now. We're literally just projecting our little drawn Perlin noise texture straight onto the material of the rectangle, which is kind of interesting, not that exciting. We're going to try and do something a little bit different with it. So I'm going to not do a basic material. I'm going to do something a little bit more sophisticated. This is called a Phong material, and it is something that you come across quite often with basic 3D rendering, and it allows a kind of a simulation of. You can throw lights onto it, you can get shadows, you can get some kind of shading, so you can get some kind of sense of the form of the thing. So it makes it a bit more interesting. Okay, you can see that Cables.GL has put a useful little warning. It's not an error, nothing's wrong, but it's saying that they've applied the default light here. And wouldn't you prefer to put something a bit more interesting onto this 3D rectangle? Okay, we've got a light that's coming from the front. We'll deal with that later, but for now that's fine. But we're gonna try and make this a little bit more interesting. So we are going to use something called a Vertex displacement map. And notice I'm just typing a part of this name, and the search in Cables.GL is pretty good. So a Vertex displacement map allows you to start playing with the vertices of a 3D mesh, a 3D object, without having to write any code. Okay, so I have got already an error happening over here. So the error is quite helpful. It just says that these ports should be connected. Texture, okay, and it's got a little red dot over the texture input port because a vertex displacement map needs a texture to do its work. So we're going to feed in the texture that's coming out of the image compose, and we're going to pass it into the vertex displacement map. You can see already that something is happening. All right, the vertices are being displaced, but it's not terribly interesting to look at. They're just kind of pulsing all over the place. And the reason for that is that we've got a very simple shape here, which has just a few vertices that are essentially around the corners of this rectangle. Right, so if we want to do something a bit more interesting, we should just have a look at how this rectangle is being made, and you'll notice that there is a structure section here that says number of columns and rows, and there's only one. So we've got a very, very simple shape. So what I'm going to do is I'm going to make a lot more rows and a lot more columns, and that's going to split it up into a kind of a grid shape so that we can actually have more vertices to play with. So I'm going to make it 32 by 32, and now we've got something a lot more interesting going on. Okay, so what it's doing is that it's taking the texture that's coming out of here, essentially the brightness values that are coming out of the texture at different pixel, and it's using that to displace, to add and subtract numbers of the positions of all those individual vertices, and that's why we're getting this nice kind of flowy thing, because the texture in the Perlin noise doesn't just go straight black and white. It goes nicely on a curve. Okay, just to prove that point, if we wanted to make it more jagged looking, make it a lot more jumpy movement, we could, in drawing this thing, we could maybe adjust the brightness and contrast of this image. Okay, so I'm going to take a brightness contrast up, and I am going to increase the contrast a lot. Okay, and you can see what's happening there. It's becoming, very black and white, and you can see that immediately this is becoming more jagged. And the reason for that is that there are now fewer nice gradations between light and dark, and so the movements, the numbers that are being added to make the vertex displacement are now changing a lot. So if I make it very black, you can see that nothing's happening. If I make it very white, you can see that now it's making a big impact. Okay, so that's kind of interesting, and it shows that you have an interesting way of, just by playing with some of these values and seeing the visual output on, in this case, a texture that's actually being. So we never see this texture directly in our composition at the moment, in our patch, but what we do see is the effect of that texture. So it's really interesting to be able to look at it in this kind of two-stage pipeline that we've set up here play with some values visually. Here we're adjusting the brightness and contrast, and see how that translates into something completely different, which is, in this case, three-dimensional coordinates of every vertex in the rectangle shape that we've made, and we've done it all with very few ops and and no code at all. All right, so cool. We've got this. We've got some interesting animation happening. The next thing I'm going to do is I'm going to make this look a little bit more interesting, and I'm going to do that by let's say I'm going to do that by tilting the rectangle a little bit, right? So because at the moment we're looking at the rectangle very much flat on, and maybe it would be interesting to see things moving from a slightly different angle, and let's also prove the fact that this is really a 3D object. It's a plane, but it is in 3D. All right. So in order to do that, we are going to transform it. Okay. So I'm going to insert something in between here, which is called a transform op. You use this very often in various places, but so it does basic things like position. So you can see that it's moving left to right here, but I'm going to use it to rotate about the x-axis. I'm going to drag this number, or maybe I'll even give it a value of 40. Okay, so we can see, kind of interesting that we can actually see now that we are looking at it from an angle, so we can see how those vertices are being displaced in a direction that's not actually straight onto our point of view. What would help here maybe is the lighting a bit, because we don't see any shadows here. We've got this very flat lighting, and remember that we had the warning about the default light being enabled. So the default light's not very interesting. It says, please add lights to your patch to make this warning disappear. Okay, so we are going to do exactly that. Before this Vong material, we are going to add a light. All right, so I'm going to do something fairly simple. I'm going to use a point light, which is a light that comes from a point and spreads out and becomes its intensity goes down as it gets further away from whatever it's hitting. So we're going to add that light. At first we see nothing, although there is a strange kind of 3D gizmo thing going on here. What is going on? All right, so I suspect that what's happening is that we've got a light that's positioned somewhere in space, and it's behind the object that we want to light, or it's nowhere near the thing that we actually wanted to light up. This type of thing might be familiar from playing around with any kind of 3D tools, but luckily we've got a visual programming environment, so we don't have to start typing in numbers. We can just play with things a little bit. All right, so I can see, okay, I can see that as I move this outwards, I do get something that looks a little bit more sensible. Okay, so I've also noticed that as I move things, the gizmo here, which only shows up when I'm selecting the point light, is also helping me to see a bit more information about what's going on in 3D. It gives me some indication that, okay, there's a light which is invisible. I can't normally see a light rendered in the scene. I can see its effects, but here I can actually get a sense of kind of where it's positioned. And we can see that already, yep, it's definitely helping with that whole issue of the thing being very flat. I'm going to maybe make it a bit brighter. The radius could be interesting. I think that's kind of how big the point is. Strange. All right, and we're going to move it around until we get something that we think is kind of interesting. I think that's pretty cool. I'm also going to move this thing a bit closer and get something a bit more dramatic. Okay, cool. So now we've got a lot more interesting light happening. Okay, so just to recap where we are at the moment, we've got kind of two stages in our pipeline. We've got a part where we're drawing some noise into a flat 2D texture that's coming out of the image compose. And kind of like the second stage in our pipeline is we've got some 3D stuff happening. I'm just going to move this a little bit to the side here. I'm going to click a very useful thing that says align left, and we get it nice and neat. Okay, so there's stage 1, stage 2. What if we wanted to do something else now? Okay, we're going to do something like a post-processing effect. We're going to make it look more interesting by taking the 3D view that we've rendered, and we're going to render that into a 2D texture, and then we can apply some filters and effects just like it was an image. All right, so that's going to lead us to our third step in this pipeline. So I think that for the third one, we're going to come off here and we're going to make another image compose, because we're going to be working with images, flat images, 2D textures. All right, so we've got our image compose ready to go to render our scene, our 3D scene, and start doing stuff with it. But we don't have an image compose kind of at the root of this whole chain where we actually draw stuff. And in fact, we can't use it in this case because this is now a 3D scene, not 2D layers or anything. So what we're going to put here instead is we're going to add an op called render to texture. Render to texture. You'll notice that straight away the output has disappeared. That's because instead of rendering all of this 3D stuff to the canvas, it's instead rendering it to a texture. Okay, so here it is. It is actually being now rendered into a new texture in this op. I'm gonna once again add this little viz texture thing just so we can keep an eye on it and see it in the editor while we're working. Okay, so we've got our 3D scene rendered to a texture instead of to the canvas. That's a good first step. Now we need to actually do something with it. So under our image compose, we're going to add a draw image op, which does exactly what you think it does. You can see it's got a warning straight up that it needs to have an image as the input to the texture. This could actually be a file, like it could be an image of a cheesy tropical island scene, which is the default, but we could also, or something we've uploaded, but we could also take this texture that's coming out of our render to texture, and we can feed that into the draw image. Okay, again, nothing visible yet on the canvas because it's being rendered by image compose. So let's do another viz texture here, just another visible, sorry. So let's do another viz texture here. All right, so big deal, we've got exactly the same thing coming out of here, but that's fine for now. What we do have now is that we've got the possibility to start applying filters and doing things, manipulating the 2D texture image. So after we've drawn the image, we can start doing things like, for example, maybe we want to blur it a lot. Can be quite fun to do a zoom blur in this case. And you can see the effect of that. We have got, God ray type blurry things happening onto the texture that we've done. That is pretty cool. Let's say that that's good enough for now. So this is kind of our third stage in the pipeline. So let's have a fourth and maybe final stage. We need to put this onto the canvas, of course, because that's kind of the thing that we've been missing for a while. There's a lot of ways to do that, but you can draw a rectangle and apply the material, for example, like you might have seen before. But a very simple way to get the final output is to add a full screen rectangle, which does what it says. And the full screen rectangle is initially, of course, gray because it's empty. But we are going to take, in this case, the final result of our third step in our pipeline, and we're going to apply that there. Okay, so now we've got the result of the third stage texture now being drawn onto screen. Great. All right. Possibly the very last thing we want to do is maybe layer this a little bit. So at the moment we have just the final image being shown. Maybe we want to put have two layers, put the unblurred image below and put the blurred image on top, and make a kind of glow effect. So there are a couple approaches to that, but the easiest would be, let's, before we draw our full screen rectangle, let's do yet another layer. So I'm just going to move this one here. It doesn't really matter where we put it, but we're going to put it over there. It's at the end still. I'm going to put another image compose. And in this image compose, I am going to draw the two layers. Okay, so I'm going to do this here. We're going to, you can see how, you can lay this out however you want, but it kind of makes sense to do it from left to right in this case. But it's good to keep these things organized so that it makes sense to you. You can see what's happening. All right, I'm going to disconnect this one. I just right clicked on there, so we're not seeing that full screen rectangle anymore with the texture coming out. Okay, so I have got this texture, which is the blurred one, and I've actually got the original one over here as well, the one that has no post-processing effects at all. So I think what I'm going to do here is I'm going to draw image, and I'm going to draw image again. All right. At the moment they're both empty, but my intention is that I'm going to take the render to texture, this one. So this is the one that has no effects on it. I'm going to draw that. And I'm also going to take the one that has the effects. I'm going to draw that next. This should be giving us already something that looks like that. Not too bad. We're going to pass this on to the full screen rectangle. We're going to get it actually rendered here. So far, not much to look here. So remember, this one is this is the untreated image. This is the image that has the filter applied. We can blend these two. All right. So you can see there, if we sort of half fade this top one in, we get a kind of a glow effect. We also have blend modes, just like you would have in Photoshop or After Effects or whatever. So we could try and add here, for example, and this could give us quite a nice kind of glow effect by adding the two on top of each other. Okay, now just to make this example more complete, I'm going to pretend that I'm very happy with the kind of prototype that I've made here, and I'm now going to prepare it to share with somebody else, so that they can view it and maybe play with it a little bit without having to know anything about Cables.GL or visual programming languages at all. All right, so I am going to add a very simple bit of UI control here. So I'm going to look for the sidebar op, remember that one, and below it, where it says the output is called children, it's the children of the overall sidebar here. I'm going to add, you can actually see the sidebar is already being formed in the corner here, but it's got nothing in it. We're going to add a slider, all right, and this slider is going to be the speed. In this case, it's going to be the speed of our displacement effect. Okay. I don't know what the range should be yet, but we'll leave it like that for now. Where can I affect the speed? Okay, so I've got a timer, which is, remember, driving this X value that's constantly making the Perlin noise move and update. So I think that if I adjust this value of the speed of the timer itself, that would be what I'm looking for. Okay, so I'm going to take the output result of my slider, I'm going to put it into the timer speed, and now I've got a controllable thing where I can go from 0 to full speed. Okay, great. So this is enough for now. I'm very happy with this. What I want my my client or collaborator or something to see is just basically this part, the canvas part with its controls, and I will show you that that is what happens by default when we share it. So so to do that, I'm going to go up to hover over the title of the patch. I'm going to hit save because that's a good idea generally for me, but I'm also going to go to patch settings, And you'll see under visibility, there's a couple of options. By default, it's private, so the patch is only, although it is stored on the servers of Cables.GL, I'm the only user who can actually look at it or edit it. I could make it all the way to public so that anyone can view it, and it could potentially be listed on the homepage of Cables.GL, but it also means that I could send a link to somebody that doesn't even have a Cables.GL account. But for now, I'm going to do unlisted view only. Okay, so that means that the URL won't be, that anyone that knows the URL can access it, but so I don't have to specifically share the project with a specific user, but it's not going to be generally accessible for anybody else. So it gives me a URL. If I take that URL and stick it into a new browser window or a new tab, let's make it a new browser window. I'm going to paste it here. Okay, and this is what the person on the other end is going to be presented with, is a nice big view of the patch that I've made, and they've got access to the UI that I built. They can make it even bigger if they want. They can even go full screen, so that you will see not even the browser around it, the browser Chrome around it. Okay, so I'm sure that you can quite easily see how useful this is, that you are able to very quickly share the latest version of the patch that you've been working on. It could be a prototype that makes pretty graphics or does sound or provides some interesting interaction. And you're able to share this simply by copying and pasting a URL. And as long as the person on the other end has got an up-to-date browser, they will be able to immediately view the patch and also be able to interact with it if you've provided ways for them to interact with it. And they can do all of this without having to download a new piece of software or pay a license. So obviously there's a lot more that Cables.GL can do, and I encourage you to explore other people's patches and see what kind of things you can make with it. But I hope that I've given you a sense of how easy it is to use, how nicely it's been put together, and how easy it is to start working in a visual programming environment, getting instant feedback when you make changes and try things out. And finally, how easy it is to share your work with other people.